All right, moving on to 12.5, you guys, Law of Cosines. This is going to be a much relief for a lot of you. I know 12.4 lessons video is pretty long. Figuring out the ambiguous case with side-side angle is a little challenging as well. So hopefully Law of Sines you feel like is a little bit of a breather and a little bit, I guess a lot easier as far as things go. So first things first, Law of Cosines, looking here. These are the formulas we're going to use. They are also on the formula sheet posted in the quarter 4 folder. I think I'm going to just keep posting it every week just so you have it readily available to you. We're not going to show you where this is derived from, so we're just going to kind of use this formula and move on from there. So there is one special kind of case we need to worry about on B, and I'll talk about that when we get to that point. So using Law of Cosines, really similar to Law of Sines, except it's different rules. And instead of using the trig ratio sine, we're using the trig ratio, the cosine. But I always like to start my problems by kind of drawing a picture to see what I'm working with. Again, your picture doesn't have to be to scale by any means. You don't have to be an artiste, but I like to label a triangle so I know B is here. And let's just say this is A and that's C. So then I know that side A is 7 and side C is 5. All right. And then we just have to go through the process of using Law of Cosines. If I'm looking for side length B, what I'm going to do is I'm going to use the B squared formula. So we have B squared equals, in this case, 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of the included angle, which in this case is 36. Again, make sure today you guys are using cosine when you type these into your calculator. A lot of times the mistake you're making isn't mathematical, it's just you're accidentally hitting sine instead of cosine. So if you don't get the right answer, I'll just double check and make sure you are in fact using your cosine button on your calculator. But if I just type this whole string of numbers into my calculator, figure it out, and then take the square root of that resulting number, to get my side length, I wind up with B is 4.2. All right. The trick today, you guys, after we get that value, remember 4.2 is a rounded approximation. So when I move into the Law of Sines to figure out my other angle pairs, even though I write 4.2, it is super important that you're using the exact value from your calculator instead of 4.2. Okay, if I use a rounded approximation, what's going to happen is you are going to be off just a hair each time. All right, so using that exact value is going to help you come up with a closer approximation instead of winding up with something with rounding error. So at this point, we use Law of Cosines once, then you can jump into Law of Sines, or you can use Law of Cosines again. It does not matter. But we simply just cross multiply, so we do 7 times the sine of 36. We divide by not 4.2, but I'm using again that stored value in my calculator. So those of you with the TI-84s, it's really easy to grab that value and just plug it into your equation. Then, since I'm looking for an angle, I'm going to take the sine inverse of whatever that decimal value is. And in this case, we get A is approximately 81 degrees. All right, at this point, the last step, really straightforward. I know I have two angles in my picture, 81 and 36, which means my last angle must be 63 degrees. Again, all of our angles in a triangle must add up to 180 degrees. All right. So that's our side angle side case. Probably should have mentioned it before, but Law of Cosines is extremely valuable for side, and side angle side. Okay, so this next case is our side case. It is extremely important that when you draw your picture here, we find our largest angle first. And a lot of us, some of us think about this. We don't know, what's bigger, A, B, or C. Well, if you remember from geometry, guys, the largest angle is always opposite the largest side. So in this case, I'm going to set up my Law of Cosines with B squared. And then I have 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of b. All right. At this point, we're going to want to solve for this trig ratio, and this is where people actually screw up algebraically, because you want to do 11 squared, you want to subtract 25, you want to subtract 64, and then you're going to divide by negative 2 times 5 times 8, or negative 80. So you wind up with a value equals cosine of b. Again, with this, you're actually going to wind up with a negative decimal value here. We'll get into this a little later, but a negative decimal value for cosine indicates we're actually in quadrant 2, which is indicative of an obtuse angle. And that's why we always start with our biggest side, because this is the only point where we could potentially catch an obtuse angle if we have it. So it's super important you find that largest angle first. And in this case, after we do cosine inverse of that negative value, we wind up with b is about 114 degrees. Okay. Again, at this point, you can break from law of cosines and use law of sines, which typically most people do. But again, super important we use that stored value in our calculator to come up with our remaining answers. So we have sine of a over 5, and we have the sine of c over 8, rather. Whoops. And then we're just going to cross multiply and solve. So we do 5 times the sine of 114. We divide by 11, and we take the sine inverse. And we get approximately 25 degrees, which then, in this case, I can either do law of sines again with my last ratio and my original, or I can just do simple subtraction, and we find out that our angle needs to be 41 degrees. All right, so that's how we do law of cosines. Again, pretty straightforward. No ambiguous case to worry about. With our law of cosines, there's always going to be a triangle that works, so you don't have to worry about 0, 1, or 2. Just do law of cosines and go from there. Again, it works for the side, and side angle side cases. All right. This next slide is a summary of things. Again, we talked about this before, so law of sines is really great for your angle side cases and your angle side angle. It also works with side angle. Okay, so law of sines works for those cases. Law of cosines is really good for side angle side and side. So that's all you really need to take away from things. Basically, if you have a side and its opposite angle, you can use law of sines. If you don't, you have to use law of cosines. All right. Very last thing you want to pull from law of cosines, you guys, is area formula again. This one's Heron's formula. You might have touched on it last year, but I'm guessing you haven't. But Heron's formula is based on, obviously, a mathematician. His last name's Heron. He derived this formula just by using side lengths. So he went a step further from using our trig ratio sine and the standard 1/2 times base times height. And he actually figured out a way to find the area of any triangle simply using the side lengths. And he found that the area was always the square root of the product of the semi-perimeter and then the difference of the semi-perimeter with the 3 sides. Okay? Your semi-perimeter is just what it means, you guys. It's half of the perimeter. So in this case, when I add up all 3 sides, we have 6, 14, and 11. So we have 31 divided by 2, which means my semi-perimeter is 15.5. So if I want to figure out the area of the triangle, I take the product of my semi-perimeter and then the difference with each. So 15.5 minus 6 is 9.5. 15.5 minus 11 is 4.5. And 15.5 minus 14 is 1.5. Again, the difference of the semi-perimeter and 3 sides, we multiply by the semi-perimeter, and then we wind up taking the square root of that product, which in this case is 31.5 square inches. So again, this formula is super handy if you're given all 3 sides. It saves you some time. You don't have to do any trig ratios to find the height of the triangle. You can simply plug in those 3 side lengths, 2 herons formula to figure out your angle. All right. Assignments on the bottom. Again, we tried to limit these as much as possible to just the basics. If you have any questions, utilize the discussion board. Next lesson is going to be the 4-5 review worksheet. And then again, the plan is to do next week some IXL modules to review our understanding of the material. If you have any questions, again, discussion board's there. Otherwise, feel free to attend my live sessions every Monday through Thursday at 1 o'clock.